Have you ever gazed at the night sky and wondered about the mysteries that Mars, our neighboring planet, holds? This celestial body, famously known as the Red Planet, is an alluring world that has long fueled our drive for interstellar discovery. Mars is a planet of diverse geological features, each narrating its intriguing and layered past. As you explore its history, you find vast canyons that dwarf the Grand Canyon of Earth, sprawling across the Martian landscape, resembling immense scars. These formations silently speak volumes about Mars' geologically active past. In stark contrast to these arid rocky landscapes, Mars also boasts polar ice caps, akin to Earth's own Arctic and Antarctic regions. These ice caps, made up of water and carbon dioxide, fluctuate with the Martian seasons, a grand spectacle of nature's rhythm in a cosmic setting. But the surprises it has to offer don't stop there. The Red Planet is home to numerous volcanic features. The most notable among these is Olympus Mons, a shield volcano that holds the record as the tallest volcano in our solar system. Its extraordinary height and extensive base are compelling evidence of volcanic activity, which has influenced and shaped its surface over eons. However, one of the most remarkable aspects of Mars is what it lacks: a global magnetic field. Unlike Earth, Mars doesn't possess a protective shield to deflect solar radiation. This absence of a magnetic field has significant implications for the planet's atmosphere and its potential habitability. Mars undergoes seasonal changes akin to those on Earth. These shifts result in a range of weather conditions, from engulfing dust storms to tranquil periods where the Martian surface lies undisturbed. Ever since the advent of space exploration, we have embarked on countless missions to understand Mars better. Each mission, each discovery, peels back a layer of this captivating planet, bringing us a step closer to answering some of our most profound questions about the universe and our place within it. As we continue our cosmic journey, we uncover more about Mars, deepening our knowledge and igniting our curiosity. Since the dawn of space exploration, we have embarked on numerous missions to understand Mars better. As we peel back the layers of this fascinating planet, we inch closer to answering some of our most profound questions about the universe and our place within it. The exploration of Mars began with the Mariner and Viking missions. These missions were our first attempts to reach out and touch the mysteries of the Red Planet. The Mariner missions, conducted by NASA in the 1960s and 70s, were our first successful voyages to Mars. Mariner 4, the first spacecraft to successfully fly by Mars, provided us with our first close-up images of the Martian surface. These images revealed a cratered, seemingly lifeless world, shattering our earlier visions of Martian canals and civilizations. Following the Mariner missions, the Viking program took Mars exploration to the next level. Viking 1 and Viking 2, each consisting of an orbiter and a lander, were launched in the mid-1970s. These ambitious missions aimed not only to orbit Mars, but also to land on its surface and directly analyze its soil. Viking 1 became the first successful mission to land a spacecraft on Mars and perform its mission. The lander's experiments sought to detect life by looking for metabolic reactions in the Martian soil. While the results were inconclusive, the Viking missions did provide us with a wealth of data about Mars' surface and atmosphere. The Viking landers also captured breathtaking panoramic views of the Martian landscape. These images revealed a dry, rocky, desert-like world, with towering volcanoes and deep canyons, a stark contrast to the blue and green world we call home. The Mariner and Viking missions were our first steps towards unraveling the mysteries of Mars. They provided us with our first glimpses of this foreign world, and their data continues to inform our understanding of Mars to this day. These missions helped us realize that Mars is not just a distant red point of light in our night sky, but a complex world with a diverse geological history and its own unique challenges. These early missions laid the foundation for our understanding of Mars. They set the stage for the many Mars missions that would follow, each one building upon the discoveries of the last, and each one bringing us one step closer to the day when human footprints may join the tire tracks of our rovers on the Martian surface. Following the Viking missions, we entered a new era of Mars exploration with the Pathfinder, Spirit, and Opportunity missions. The Pathfinder mission, launched in December of 1996, was a bold venture that marked a shift in Mars exploration. Instead of focusing on the atmosphere like previous missions, Pathfinder aimed to investigate the Martian surface. It deployed the first successful Mars rover, Sojourner, which served as a proof of concept for future rover missions. Its findings showed Mars to have a diverse and complex geological history, opening up new possibilities for research. Following Pathfinder, the twin rovers Spirit and Opportunity took center stage. Launched in 2003, these rovers were designed to roam the Martian surface for 90 Martian days, known as sols. But they exceeded all expectations. Spirit lasted until 2010, while Opportunity continued exploring until 2018. Their longevity allowed them to cover vast areas, providing us with a detailed understanding of Mars's terrain and geology. The real game changer, however, was the discovery of evidence of past water on Mars. Spirit found deposits of a mineral called goethite, which forms only in the presence of water. Meanwhile, Opportunity discovered tiny spheres of hematite nicknamed blueberries, another sign of liquid water in Mars' past. This was a significant leap forward, as the presence of water is a key ingredient for life as we know it. These missions also revealed Mars' dynamic nature. They showed us that Mars experiences seasonal changes, much like Earth. This understanding has helped scientists better predict weather patterns on Mars, a crucial factor for future human missions. But perhaps the most enduring legacy of these missions is how they have humanized Mars. They've turned the red planet from a distant alien world into a place we can imagine exploring ourselves, a place with a history not so different from our own. These missions expanded our understanding of Mars and its potential to support life. The most recent missions, Curiosity and Perseverance, have taken Mars exploration to new heights. Launched in the years 2011 and 2020 respectively, these rovers have unveiled a new era of discovery on the red planet. Curiosity, the car-sized rover, was designed to explore the Gale crater on Mars as part of NASA's Mars Science Laboratory mission. Its main goal? To find out if Mars could ever have supported life. Curiosity has been a trove of discoveries, from ancient riverbeds to the complex chemistry of Martian rocks. But perhaps its most significant finding is the detection of methane in the Martian atmosphere, a gas often associated with life here on Earth. Fast forward to 2020, and we have Perseverance, the most advanced rover NASA has ever sent to Mars. Its mission? To seek signs of ancient life and collect samples of rock and soil for possible return to Earth. The rover has been busy searching for biosignatures, signs of past or present life, and analyzing Martian meteorites. It's even equipped with a mini helicopter named Ingenuity, which has successfully demonstrated powered flight in the thin Martian atmosphere. In addition to these rovers, there are ongoing scientific endeavors that are helping us understand Mars better. Scientists are studying methane in the Martian atmosphere, searching for biosignatures, and analyzing Martian meteorites that have landed on Earth. These efforts are helping us piece together the puzzle of Mars's geological and biological history. From the riverbeds discovered by Curiosity to the potential signs of ancient life sought by Perseverance, we are learning more about Mars than ever before. And with each new discovery, we get one step closer to answering one of the biggest questions in space exploration. These missions continue to uncover the secrets of Mars, bringing us closer to answering the question, is there life on Mars? The exploration of Mars doesn't end here. The future holds exciting possibilities. We are standing on the precipice of an era brimming with potential, where we not only continue to explore Mars, but also plan to make it a second home for humanity. Future missions are set to carry out the ambitious task of collecting and returning samples from Mars. This will provide us with invaluable data, enabling us to delve deeper into the Martian environment and unravel its geological secrets. These missions are also equipped to study the challenges posed by microgravity, which is crucial in understanding how to sustain human life on Mars. But Mars is not just about the planet itself. Its moons, Phobos and Deimos, have piqued scientific interest. These celestial bodies, despite their small size, hold clues about the early solar system and the processes that led to the formation of planets. Future missions aim to study these moons, seeking to uncover their mysteries and their potential for supporting future space exploration. As we set our sights on Mars, our ultimate goal is to establish sustainable habitation. This means creating an environment where humans can live and work for extended periods. This is a complex task that requires overcoming numerous challenges, from ensuring a stable supply of resources to developing technologies that can withstand the harsh Martian conditions. Simultaneously, Mars exploration is fostering global collaboration. Countries around the world are uniting in their quest to explore Mars, sharing knowledge, expertise, and resources. This global endeavor not only propels us closer to our goal but also symbolizes the unifying power of human curiosity and the pursuit of knowledge. As we continue to explore Mars, each mission brings us one step closer to unraveling the mysteries of our neighboring planet.